In the first part of this series, we looked at what blend is. In this second part, we are going to look at join and relationship. Blend, join, and relationship are three ways that Tableau enables us to combine different related tables and data sources together. These three, in general, allow us to combine our data horizontally based on some common fields. I'll see you in a bit. We're using some fictional datasets for this video. One is an Excel file that is a customer master list. A second one is a customer order. So a customer may have ordered 0 times, 1 time, or multiple times. The third one is a master list for products. It contains information like product ID, category, subcategory, product name. So these are the three Excel files we're working with. Note in here that customer ID in the customer's Excel file is not the exact same value as the customer ID you find in the customer orders Excel file. We also have product ID that links products and customer orders. Note that not all products exist in customer orders. Some of them may not have been bought yet. As a recap, this is the matrix we are using for comparison. We covered and demonstrated these factors in Blend in part 1 of this series. If you haven't seen that video yet, I will provide a link in the card above and the description down below. We need to note a fundamental change in how Tableau structures and works with data. Starting version 2020.2 onwards, Tableau has introduced the concept of a data model, and this is a way that Tableau now separates what it calls a logical layer and a physical layer. It's worthwhile to take a look at what the default interface was and the default behavior was before 2020.2. So this is version 2020.1. This is before the big data model change. Let's take a look at how Tableau behaves when we try to combine multiple files together. So I'm just going to drag over customers first, and let me drag customer orders after. Notice in here that the default connection that Tableau gives us is what we call a join. This is identified by the Venn diagram. And from here right away, we can change the type of joins. We can make this an inner join, a left join, a right join, or a full outer join. Now let's compare this with the default behavior that we see now in the newer version of Tableau. I will drag the same two files, so let's drag customers first. Let's drag customer orders after. Notice in here that we don't get the combination of the two files right away, not like in the older version. And when we drag over customers, it actually does not give us the Venn diagram right away. It is asking us how we want to edit the relationship between customer and customer orders. So starting in version 2020.2, we now have what we call a logical layer and a physical layer. A logical layer is what will be considered as tables as far as Tableau Desktop is concerned. This is going to be the unified set of rows and columns that you're going to see when you're working in your canvas. The physical layer is what makes up the logical layer. So in reality, there could be multiple physical tables that make up a single logical layer. When we work with it in Tableau Desktop, we don't see this physical layer. For us, it's as if we have a single table. Relationships live in the logical layer. What we establish when we create relationships are just that, relationships. All we are saying is that these tables are connected, but we are not bound to the type of operation we need at the time that we're connecting to the data. Tableau helps us with this once we start building our visuals. Joins live in the physical layer. It helps us construct what will eventually be seen as tables in Tableau Desktop. One analogy we can use for this kind of abstraction could be our phones. What we see is a really nice, elegant device. This is the logical layer. It's presentation ready. But we need to understand that behind the scenes, there are a lot of components. On the surface, it looks like a single device, but many pieces are put together to make this work. This is the physical layer, and what we put on the physical layer is pretty static. It will be hard to change. So now let's dive into joins. A join is a way for us to combine data horizontally. Tableau usually represents this as Venn diagrams. We can do an inner join, a left join, a right join, a full outer join. We can also join based on calculated fields. It's important to note that not all data sources support all 4 types of joins. In this video, we're not going to have a deep dive on the different types of joins. If you're not familiar with the concept of joins, I will recommend checking out another video that I have on database joins. I will link it up in the card above and the description down below. While this tutorial is not Tableau specific, the join concepts are pretty much the same. So let's demonstrate in Tableau what happens when we do joins. And by demonstrating some of these concepts, we will get an idea why relationships were introduced. For this demo, let's take a look at salary. Note in here, customer IDs don't have the exact same values, so we are going to have to join on calculated fields. Now it's also important to note that some of these customers may have ordered multiple times. So for example, Mario ordered one time, Luigi ordered twice, Princess Peach ordered 3 times, Bowser ordered a lot of times, and Yoshi did not order at all. So let's start again by looking at customers and customer orders. This layer that we have right now is the logical layer. And we're going to see that as we hover over this box, it actually tells us this is a logical layer. And if we wanted to go to the physical layer, we can double click on this box. Once we double click, we can see that this is the same interface we had in the previous versions of Tableau. While we have the physical layer open, let's select on customer orders. Let's drag over customer orders. And we will see in here that by default, it is giving us an inner join. And we know that the IDs are actually different. So we have to create a calculated field. We need to join on a calculated field. So clicking on this Venn diagram, we're going to change customer ID from the customer's Excel file. We're going to use a join calculation. Let's close this physical layer and take a look at what happens to salary. If we want to close this physical layer, we simply need to click on that X on the right-hand side of this rectangle. And notice in here, it brings us back to the logical layer. And the logical layer even has an indication that there are joined tables underneath in the physical layer. And before we create a new canvas, we can already see that there is some duplication that's happening. We see that Mario appears one time because Mario ordered only one item, but Luigi appears twice because Luigi has 2 matching records in the customer orders file. And it should be evident now that what's going to happen to salary is it's going to be overstated. Instead of 50,000, Luigi will get 100,000. So let's take a look at that. So in sheet 1, let's put customer ID, let's put the name. Maybe we want to display all of their sales, but if we wanted to display their salary as well, then we can see that again, the salary is overstated. We are also seeing that we are missing one customer. Yoshi is not here because Yoshi has not bought anything yet. So with an inner join, which is a destructive join, we are losing one record. So if we wanted to add Yoshi, we want to go back to the data source, to the physical layer, and change the type of join. We need to make this some kind of an outer join. And in here, we can choose a left join so that we are preserving all the records from customer. So let's go back to the sheet, and now we see Yoshi. With regards to salary, in the past when we have this issue, one way we get around this is by using our level of detail expressions. So to properly display salary, we could create a fixed level of detail expression. So on the drop-down, create calculated field. Let's call this fixed salary. This is going to be fixed by customer ID. And let's say this is going to be the minimum of the salary. Because remember, salary is just duplicated. It doesn't matter if we choose minimum or maximum or average, it's going to be the same number, at least for this use case. And let's click OK. And when we display our fixed salary now, this is the correct number. What if we want to add information about the product? Let's say we want to display the product names. This means that we need to add product list to our existing data source. Let's take a look at how Tableau behaves in this case. So let's go back to the data source. And in here, we are still on the physical layer. We can add products. And from here, we can drag over product list. And let's take a look at what we have. What we can see in here is we are missing customer number 5 again. And the reason for this is customer and customer orders, they have been joined first, and we are preserving customer at that time. But then the result of this gets an inner join with product list. And remember, inner join is a destructive join. If there is no matching value, then it's going to eliminate that record altogether. So in this case, Yoshi hasn't ordered, so the record for Yoshi or customer number 5 has been eliminated. And if we wanted to preserve that, we need to make sure that these joins are left joins all the way through, or some kind of combination that allows us to preserve customer. So in this case, it's just going to have to be a left join. So let's go back to sheet 1. So now we see Yoshi. But then a second issue could be that in another worksheet, I want to display all products whether or not they have been ordered. So if we simply check the product list from this connection window, so view data, on its own, there are 36 products. But when we go to a sheet and try to display it, we are going to see only 21. And we also have a record here that is null. And it's because not all of the products have been matched. So we might think, oh, maybe we should just go back to the data source and then change this to a right join. Again, this messes up our worksheet. So now we have lost Yoshi again, but we are introduced to a null customer because there are products that have not been bought yet, therefore not matching a customer. And the solution is really to create multiple data sources. And this is why relationships have been introduced, and this is why relationships are so useful. So joins allow us finer control over the data source. We can decide if we want to have an inner join or an outer join. We can decide if we want to preserve records or not include them altogether. But the tables we create using joins are very static. If we require different joins for different kinds of views, let's say an inner join for one worksheet and an outer join for another worksheet, it means that we have to create different data sources. And also because of the nature of joins, we are potentially going to get some duplicated values for some columns, for example, salary. And our typical workaround is a level of detail expression. So joins are powerful, but it's not without its limitations. So let's take a look at relationships now. This diagram is lifted from the Tableau online documentation, and I think this summarizes the power of relationships. The advantage of relationship is really on the flexibility. It's really about the smart aggregations and contextual joins. And what this means is Tableau watches for context. It takes a look at how we're using the data, and it may alter the type of join that is needed or the type of aggregation that's needed based on the fields that we're dragging to our canvas. So let's take a look at this in action. So let me drag over customers. In here, I'm just going to connect to the other two Excel files as well. So customer orders and products. And let's drag customer orders over. And notice in here, we have this flexible line. It's not a Venn diagram. It's just a flexible line called the noodle. And this signifies the relationship. And remember, the relationship is simply a statement. It's like a contract that tells Tableau these two tables are related by this field. And that's all we're saying. We are not committing to a type of join. We're not saying this is an inner join or a left outer join or a right outer join. Now, starting version 2020.4, we can actually create relationships on calculated fields. So in here, I'm just going to click on customer ID. I can edit the calculation for customer ID because I know that does not perfectly match the customer ID in customer orders. So in here, we're just going to type in customer, plus. And let's just simply drag over products. So click on products and drag over product list in here. Tableau will by default choose those. Now there are other options for relationships. So under the performance options, we can identify the cardinality and the referential integrity. We can define these. We can give Tableau hints as to what the cardinalities are, and cardinalities typically mean the number of records that are related on both sides, but the default settings are recommended. I will go through these options in more detail in a different video. So let's close this. Now, another thing we're also going to notice is that when you click on customer, it only shows the fields for customer. It doesn't show any of the related fields from the other tables. And you're going to notice the same thing for customer orders. It only shows fields for customer orders. And for product list, it only shows the fields from that table. So let's go to sheet 1 and let's take a look at the initial issue we had for salary. Let me just change the sheet name. And remember, the issue we had is salary became overstated for any of the customers that ordered more than once. So in this case, if we want customer ID, let's put the customer name. Let's double click on sales and let's also double click on salary. Notice in here that we did not have to create a level of detail expression. The aggregation is still a sum of salary, but we're getting the correct salary for each of our customers. And this is because the sum of salary is only applied to the customer table, and the customer table only has one record per customer. Notice in here as well that by default, it actually has retained Yoshi. So without me specifying the type of join, Tableau has been able to identify that since I dragged over from a customer first, I probably want to retain customer. What if we want to only look at customers that made a purchase? Well, we have a couple ways. The first way is to have a filter. Filter anything that doesn't have a sales value. Another option is for us to start from customer orders. Let's create a new worksheet. Let's drag over customer ID. We can drag over the name and then sales. So without us needing to specify, Tableau only gives us all customers that have made a purchase. However, we have to be careful because if you start adding a measure that comes from a different table, so for example, if we double click on salary, we're still going to see the customer who hasn't purchased. So at this point, we just need to make sure we have the proper filters so it doesn't show. Let's create a third worksheet. If we wanted to see all the products in our product master list, we can simply drag over our product ID and we can see in here that it matches the 36 records we have in our raw Excel file. We did not have to go back to our data source and change the type of join. We also did not have to create another data source altogether. So relationships are more flexible, they are context specific, but some of the current limitations, at least as of the version of this video, we cannot join on geographic fields. Joins actually allow us to join on geographic fields. So for example, in here, if I have multiple tables that have geolocations, I can simply drag these fields over and I can choose to use an operation called intersect that checks if a point is within a polygon or a point is within another point. At the time of this video, we also cannot define or edit relationships on published data sources, nor does it support circular relationships. I definitely encourage you to look at the online documentation to look at the full list of limitations for blend, join, and relationship. Let's now summarize blend versus join versus relationship. This was the matrix we were looking at. We know the visual cue for blend is a linking field or a chain. With joins, it is a Venn diagram. And a relationship, it's simply a line, which we call a noodle. In terms of data sources, a blend will have multiple data sources. The first data source you drag a field from will be the primary data source, and it can have multiple secondary data sources. A join is technically just a single data source. It will be represented as a single database symbol in your sidebar. It's the same with relationship. In this case, the join and relationship look exactly the same. Now, in terms of number of connections, all three of them are technically the same. Each one of them can have multiple connections per data source. As far as structure is concerned, we can see in here for a blend, the blend actually shows us the underlying data for a data source independent of the other data source. For example, in here, we see customer separate from customer orders. For a join, since this is happening at the physical layer, this automatically gives us just a single table view. It's a combination of rows and columns from the joined tables. When we create our canvas, what we see is one set of dimensions and another set of measures. With relationships, we can see that as we select each logical table, it gives us a separate view from the other logical table. This is also evident in the sidebar. We can see that each table is treated independently. The customer table has its own dimension and measure. The customer table has its own dimension and measure as well. In terms of how the tables are combined or connected, the blend is connected using a linking field, and this can be defined when we edit the blend relationships. The joins are happening at the physical layer, and the relationships are happening at the logical layer. It's important to note that as of version 2020.4, both join and relationship can accommodate calculations for the fields that you're joining. And how numbers are aggregated, the granularity of the blend is always dependent on the primary data source. Whereas with join, it's based on the join level granularity. It's based on the resulting record of the join. With relationship, it has smart aggregations. It will do the aggregations and the joins based on context or based on how you're using your fields in the visualization. And this is just a quick recap of the sidebar differences. In your blend, you're going to see multiple data sources. You're also going to see the blending fields. In your join, you're going to see one set of dimensions and one set of measures, but you can still see where these dimensions and measures are coming from. However, for relationships, you have a more independent view. One logical table will have its own dimension and measure. So in this case, you have customers with dimension and measure. You also have customer orders that has its own dimensions and measures. When I was first learning blend and join in Tableau, I was given this advice: join if you can, blend if you must. But now that we have relationships, I'd like to amend this advice. Use relationships if you can, join if you must, and blend if you absolutely must. I hope you enjoyed this video. I hope this gave you a clear comparison of blend, join, and relationship. I'll have future videos with deep dives on join and relationships. And if there's any other topic that you're interested in seeing in this channel, please let me know in the comment below. If you haven't subscribed yet, please consider subscribing. I would really appreciate your support. Thank you so much for watching, and I will see you again next time.